Welcome in. All right, so let's try to break down and see the difference between a transverse and a longitudinal wave. So when you're just getting introduced to waves, so waves are caused by vibrations. I'll put up a link up above there, okay, to the introduction into vibrations. And waves, so the word wave, you can actually tie in directly towards energy. So energy being transferred amongst particles. And there's two ways that we see this transfer happening. One way is transverse, and the other one is longitudinal. So what is the key difference? So within here, here's the actual definitions of the two. Now the first definition, so when particles, and you can imagine that you have these particles kind of lined up side by side here, so I'll try to simplify it, but I think it will show you what the concept is. These particles can move or they vibrate, and they can vibrate, okay, up and down or side to side or any way that they like. Now, when we are talking about a transverse wave, what we're talking about is that the particles are moving or vibrating perpendicular to the direction of energy flow. So what does exactly that mean? Okay, so let's try to figure this out. So this entire definition, when we say that particles are moving, and the key word here is perpendicular to the energy flow, then what we are referring to first, energy flow is the word wave. So that's what we have there. The particles moving perpendicular means the following. If this particle, okay, so if it's caused by some kind of a disturbance and a vibration is caused, and this goes up and then it slowly starts to come down and it continues this pattern, so it goes up and it goes down. As you can see here, so you have a numerous set of particles, and these particles are tied in by some bonds, some kind of forces that are keeping them in. You can think of them having an actual string or even some kind of a slinky like, okay, that you have in there that's tying them in together. So if I move this particular particle, so if I move this up, if this particular chain, okay, wants to stay together, then what's going to happen is that because of the fact that there is a force that is holding these things together, then automatically what's going to happen is that this one, to keep the force, is also going to start to move up. Now, as this also starts to move up, it also starts to pull this, and it also starts to move up. And this continues. So as you can see here now, it kind of goes and starts to shift upwards, okay, as we're going through. But now, if the vibrations continue, then, well, this particular particle, okay, is going to get shifted, and it's going to start to move down. Now, as it moves down, this one, not instantly, okay, but after just a slight little delay, it's going to try to keep its momentum, and it's going to try to still continue up because that's what it was trying to do as this one was being pulled upwards. But if this abruptly starts to come down, this still for a little bit kind of starts to go up. And this, of course, there's almost like a delay where this also starts to go up. And you can see that now it starts to create this pattern of a wave. Now, this pattern of a wave, of course, if this continues to go downwards, it eventually is going to stop this from going upwards, and it's going to say, whoops, I'm getting carried too far away, and I'm going to try to follow this lead, and it's going to start to come down. And the same thing will happen, okay, within here. So this one eventually first will try to go up, okay, and then, this one is going to pull up this one, okay, and it's going to create this pattern of a wave. But as this goes downwards, notice that our wave is actually shifting in this direction because of the fact that we're pulling this up and then pulling it down. So that's the vibration that's caused. But because of the delay, so it first continues upwards and it pulls the other one upwards, and then eventually they just kind of slowly come down. Now, when you're pulling it down, the motion of these particles is actually perpendicular to the motion of the transfer of this wave that you're having. And that wave continues on. So if you were pulling these upwards, it would create this nice pattern where, it goes up, okay, this one comes down, and this one starts to follow, but then these still get pulled up, and it looks like a nice, beautiful wave that we can have. So eventually, what would have happened is, you would have had this pattern continuing on. Now, of course, that's on the assumption that this is cyclical and it keeps going up and down. And the fact that your particles are moving perpendicular to the direction where that energy flow, meaning the wave, is carried forward, so this is being carried forward in this direction, that is called a transverse wave. So now, what's the difference between a transverse wave and then a longitudinal wave? So if now I take this in, well, here is some concepts with regards to a longitudinal wave. So in a longitudinal wave, the particles, they also move or vibrate, but now parallel to the direction of energy flow. Okay, so let's think about that, and we'll get into this compression, rarefaction, and also kind of the first introduction to sound in just a moment. So what does it mean for these particles to move parallel? So I'm going to try, again, to utilize this concept right here. Okay, but now I'm going to kind of duplicate it and bring it downwards. And what I'm going to do now, so because of all of these, nice particles that I had, so all of these particles initially, okay, as they were started off, so they started off right beside each other. Well, so now what I'm going to do is I'm going to do the following. So imagine instead of moving this upwards, okay, so I move it back, okay, and forth, back and forth. So what would I do if I start moving this backwards, okay, over here? What would happen? Well, so again, this is like, having a slinky, okay, right here that is tying this in, so or a little spring that's tying these things together, or there's a little bond or the forces. Now, of course, when I move this thing upwards, the other one just followed it. So it just basically went upwards as well. So now if I'm going to move this from side to side, so instead if I move this way, well, what's going to happen? Well, this is going to try to follow it back into here. And then, of course, this one is going to try to follow this back into here, and so on. And now what would happen is that as these guys come together, so maybe, what I'll do now is this kind of carries forward. So instead of pushing it continuously back, I will say, oh, okay, now we want to push this one back in. And if I push this one back in, well, then all of a sudden, this one is going to get knocked in and it's going to start to follow in this direction. Okay, so it's going to try to come back in this one. Okay, and then this one is again going to try to come back, okay, and go to this direction. And now what you're going to have, and I'm going to try to show this in a little bit of a spread out motion. So let's keep these a little bit further apart. Okay, so we're going to try to put them a little bit further apart so it just kind of shows exactly what is happening, okay, within here. And, you can imagine that there is some kind of a spring which is tying these things together, okay, as you're going through. So there's some distance in between. So please remember that for particles, they're not exactly stuck together, right? So there is a distance and then there's forces in between that's allowing them to some movement or vibration. So when we have these items and they're actually being shifted back in, so if this one shifts back in, okay, this one is going to be further apart. Again, it's going to have a delay, but it's going to try to go back in there. So when these two come together and then when they start to move apart, okay, so as you're going through and this one gets pushed in there and then maybe this one gets pushed in there. So what's going to happen is that these particles are actually moving now parallel to the actual motion or the energy flow. But this isn't like what you think of a wave where it's going up and down, what we typically think of a wave, okay, even if it's, within the ocean or water. So these waves look a little bit different. These waves are created by kind of compressing in, okay, and then relaxing back. The compression means that particles are coming together, okay, and then the relaxing back where they're a little bit further apart now is called the rarefaction. And that's what we utilize, and these are for longitudinal waves. So longitudinal waves don't have this up and down motions that we see, but instead they get compressed in, okay, and then relax back. And then what happens is you have moments where you have these guys coming in together, okay, and then some other guys coming in apart. So if I continue this, maybe these guys are going to start to come together, okay, and then it's going to start, and these guys are going to come apart. And this just pattern continues on. So it goes in together, and then it will start to spread apart, and then pull it backwards, okay, and it looks like it's moving in a longitudinal pattern in between compressions and relaxations. And you can think about, if you have a slingy and you just slinging it back and forth, okay, so maybe I'll put a little shot up there, okay, from the textbook, okay, that you'll see within. So those ones, okay, they're compressing in and then they're relaxing back, but they're moving longitudinal, and the particles themselves are also moving in the direction back and forth where the energy is flowing. Unlike a transverse wave where the particles are going up and down, okay, and then it creates this pattern within a wave that we're much more used to. So remember that compressions are for longitudinal waves, and that's when the particles come together, and rarefaction just means that the particles are moving apart. So it's the process of moving together and apart, and it is moving back and forth in a parallel path towards the wave or the energy flow. Now, the one component which is very interesting and a very special case of longitudinal waves, something that we're used to, and the reason, if you're lucky enough, okay, that you're able to actually hear the sound within here. So it just depends, okay, on your eardrums. So sound is a wave. Now, what kind of a wave is it? It's a longitudinal wave. And it is a wave which is caused within the air where there are particles. So there are indeed kind of compressions and rarefactions between those particles within the gas that are passed through. The vibrations are caused by our vocal cords, and that actually pushes out, and the sound or any medium gets transferred in. And if it is capable by our ear drums to pick up what we call sound, really sound is a wave, meaning energy. So if our ears can pick up that energy between those particles shifting and then transfers it back into our brain so that we can decode that energy, okay, that hearing sound is what we call the sound wave. So a sound wave is a longitudinal wave. It's not a transverse wave. So it's a longitudinal wave that occurs that our eardrums are capable of picking up. And if we are incapable of picking it up, then it is not sound. Okay, so there is very high pitch or very low pitch. Some of them we don't actually hear, meaning those kinds of energies, our mind and our brain is incapable of transferring back that energy into sound. So that is the first slow introduction towards sound. So it gives you kind of a priming mechanism as you keep studying, and there'll be more to say about sound in future videos. Now, the last thing that I'll mention here is that waves actually are pretty complex. So they don't just come either as transverse or longitudinal. Sometimes it will have a combination of both. So what do we mean by a combination of both? You know that particles, as they're moving along, they may not just move, right, up and down or side to side. They can move in all kinds of different directions. And because of that, they may actually create both longitudinal and transverse waves. So if I would hit on this desk, okay, so it would create both transverse and longitudinal waves because of the hit, the particles there that you have, and if I just keep hitting it back and forth and making it vibrate, so the particles both will kind of shift up and down and also side to side, creating both kinds of waves. So that's it in terms of this introduction. I hope that the key is that you understand the difference between the movement of particles and the propagation of the wave. So if it's perpendicular, then it's transverse, okay? If it's parallel, then it's longitudinal. And sound is just a special case of longitudinal that our ears are capable of picking up that energy and decoding it. Thanks for watching, okay? Happy compression and rarefactions. See you in future videos. Bye, everybody.